Today we are going to look at simplifying rational expressions. So we need to review our factoring steps. So the first thing we're going to do when we factor is we have to always factor out the GCF. Then we will look to see, do we have a difference of two squares? Remember, a difference of two squares is if we have two monomials and they are separated by a subtraction. If we don't have the difference of two squares, then we are going to go factor. So simplifying rational expressions basically is where we have polynomials on the top and the polynomials on the bottom, numerator and a denominator, and we're trying to make that smaller and simplify. So fractions like 5/9, 7/12, and 1/2 are rational numbers because they're already fractions. An expression that can be written in the form of polynomial over a polynomial is a rational expression. So that means that we'll have an expression on the top and an expression on the bottom. So a few examples are 1 over x, x plus 2 divided by x minus 3, x squared minus 5 divided by x squared minus 10x plus 25. So these are all examples of rational expressions. We are going to try to find factors for the numerator and the denominator we can cancel out. So I want to review how to cancel. So notice 2 divided by 2. This is the identity. They look exactly alike. So 2 divided by 2, we can reduce that down to 1 over 1. And so that is going to be 1. So notice they look exactly the same. X minus 2 is an expression divided by x minus 2. These look exactly the same. This is going to equal 1. And it is not because I can divide x divided by x and 2 divided by 2 is 1. That's not the reason. It's because this is one expression. The expression x minus 2 divided by the expression x minus 2 is equal to 1. So because they are subtracted by a negative, they have a subtraction sign, you cannot just go in and cross out the x's. You have to go in and look at and make sure that they look exactly alike on your expressions. So for example, if I have x minus 4 divided by x minus 2, these do not look alike. So I cannot go ahead and cross out the x divided by x and say that is equal to 4 divided by 2, which is 2. That is not a true case. This expression is going to stay as x minus 4 divided by x minus 2. The reason is because if I go put in, say, x is equal to 7, I would have 7 minus 4 all over 7 minus 2. And so that is going to give me 3 all over 5. If I go in and say that this expression is equal to 2 because I went in and crossed out these x, 4 divided by 2, and say that's 2, well, 4 divided by 2 is not equal to, in this case, what we just said, which was 3/5, because I put in a variable. This variable means that I should be able to put in a variable. I should be able to go find what x represents. So do not cross these out if you have expressions. You put parentheses around that to remind you that eventually this is going to be a number. X squared minus 1 divided by a negative 2. So I have to go factor this. This is the difference of two squares. This is x minus 1, and this is going to be x plus 1 divided by a negative 2. I can't just go in and cross out these negative 1 all over 2. They have to be the same. So there's nothing that I can do right here. All right, I want to go ahead and simplify. So I have 6x to the 4th divided by 18x squared. This right here is just your basic division. So I will have 6 and 18 together, and if the bases are the same, I'm going to keep my base and I'm going to subtract my exponents. And so this is going to be 1/3 x to the 4 minus 2, and this will be 1/3 x squared, or you can write it like this, something similar to that. On letter B, first thing we're going to do is we want to pull out our greatest common factor. Our greatest common factor is 3 on top, and so I'm left with an x minus 2, and then I have a 6 on the bottom. I am multiplying these two factors, and so I can go and simplify that. And so I can take a 3 out of the 6, and I'm left with a 2. And I'm left with x minus 2 on the bottom, on the top, and a 2 on the bottom. This right here is an expression, x minus 2. I cannot just go cross out this 2 and be left with a 1, an x minus 1. This is my answer right here. This is a number eventually, x minus 2 divided by 2. Because this negative in between this, I cannot just go in and cross out one number. Whatever I do to my expression, I have to do it to everything. 21x squared y divided by 14xy squared. I have multiplication. There's not an addition and subtraction in between, so I can just go do early division. 21 divided by 14, I can go ahead and group that. Group my x squares together, and I can group my y's together. And so 21 divided by 14 is going to be 3/2. If the bases are the same, I'm going to keep my base, and so this is going to be x to the 2 minus 1, which is 1, and then y to the 1 minus 2, which is going to be y to the negative 1. We can't leave it with a negative, and so we'll have 3. The x goes on top, the 2's on bottom, and the y goes down here. All right, letter D, x squared minus 5x divided by 5x minus 25. So now I have a binomial. When I have a binomial, I have to factor this. So I will have an x, because my greatest common factor is x. I'll pull that out, and I'm left with x minus 5. First step to factoring is finding the greatest common factor. My greatest common factor is 5, and I am left with x minus 5. So now I'm looking to see, is there anything that I can cancel? So I have an x minus 5 on top, and I have an x minus 5 on bottom. So I can cancel them out, because this is going to be left with a 1, and that is a 1. And so my answer is x divided by 5. Letter E, I have a binomial divided by a binomial. So I can't just go cross out one of the x's on the bottom and one of the x's on the top, because I have this addition here. First step to factoring is pull out the greatest common factor. So the greatest common factor is going to be x squared. I'm left with x plus 1. And then I have x plus 1 on the bottom. I like to put parentheses around my expression so I can remember that this is one single number. I have an x plus 1 on the top, and I have an x plus 1 on the bottom. And so when I cancel out, I'm left with 1. Well, x squared times 1 is going to give me x squared. And there's nothing on the bottom except for a 1, which I don't need to write. Letter F, I want to go factor the top. I have a trinomial, which I will factor. I look to see there's not a greatest common factor other than 1. And so this sign tells me that both my signs are going to be positive. I'm looking for two numbers I multiply together that will give me x squared. And so this is going to be x and x. And then two numbers I multiply together that will give me 2 that will add up to 3, and so I'll have 2 and 1. Greatest common factor always pulls out first, and that's going to be x squared, and so I'm left with x plus 1. So x plus 1 divided by x plus 1 will cancel out, and I'm left with a 1 and a 1. And so then I have an x plus 2 on the top, and then I have an x squared. I can't cross out the x plus 2 with an x because this is one single number. So I have x plus 2 divided by x squared. All right, so 3x plus 3y. My greatest common factor is going to be a 3. I'm left with an x plus y. On the bottom, my greatest common factor is an x. When I pull that out, I'm left with an x plus y. I have an x plus y on the top. I'm left with a 1. When I take out that, I'm left with the 1. So we have 3 all over x. And I'll do one more, and that is letter H. So I have a trinomial that I can factor. This becomes x and x. This tells me my signs are going to be different, so I'm looking for two factors that I multiply together that will add up to 2. And so I can have 1 and 15 and 3 and 5. My inners have to be a positive. So I have a positive 5 and a negative 3. So 5x minus 3x gives me a positive 2x. And the same thing, I have my trinomial that I'm going to write as two factors. I'm looking for two numbers that when I multiply together, I know my signs are both going to be negative. I'm looking for factors of 12 that add up to a negative 7. So I can have 1 and 12. I can have 2 and 6 and 4 and 3. So I have x minus 3 cancel out, and this has left me with a 1. And so I have x plus 5 all over x minus 4. I do want to go back in, and if I gave you 7 plus 3 divided by 3, could I go in and just cancel out this 3 and this 3? No, I can't, because I'm not going to be left with a 7. So the exact same thing applies to my rational expressions. If I had an x plus 3 divided by a 3, I can't just go cross out those 3's and be left with a x. So that's the reason why, because there's an addition between those. If I had multiplication, then yes, if I had 7 times 3 divided by 3, yes, I could go do that because there's multiplication, but if there's an addition or subtraction in between, I cannot. So I just wanted to clarify that. Okay, so I will do a few, just one or two of the homeworks with you. 1 through 6 is just going to be simplifying. That's your exponent rules. Looking at number 7, so I would have n plus 6. First thing I look for at the bottom, greatest common factor, I know is going to be 3. So when I take out a 3, we're left with n plus 6. So when I take out the n plus 6, I'm left with a 1 on top, and I left with a 1 on the bottom. So notice I have a 1, and then I have a 1, and then we're left with a 3. So all of that reduces down to 1/3. I'll do number 9, and then you'll be on your own. This is the difference of two squares, and so I have a y minus 8, and this is going to be a y plus 8. Doesn't matter which order you put those in. And then I have a y plus 8 on the bottom. So they're an identity, and so when I'm left with a 1 here and a 1 there, so I have y minus 8 all over 1, which is equal to y minus 8.